So I'm Jean-François Ayme. I'm a research lead in automation for organic chemistry, and I work at the University of Liverpool. So we are currently looking on how we can apply data-driven science to chemistry to enhance innovation in the chemical space. So NMR is quite complementary to other techniques like mass spec to give you a full picture of what is happening in your chemical reaction. And more or less for some of the topics we are studying here, like supramolecular chemistry, or in the case of catalysis, it can really give you insight into your chemistry, into the mechanism that other technique cannot give you. Like, for example, in the case of host gas binding, in the case of the creation of complex architecture, or in the case of determining which type of enantiomer you have in your reaction. One problem for applying any type of data-driven technique in chemistry research is the lack of data that currently exists in chemistry. And when you want to collect the data you want for machine learning or any AI, you want to do this in a very standardized way, so this data is reliable. And automation is the right medium to do so, because it first gives you the standardization that you need, but also gives you the throughput that you need to produce enough data of high quality for training any type of AI you want to use later on. The Benchtop NMR is really the key companion to the iSynth, because you don't need to use any deuterated solvent, so that facilitates things and reduce costs considerably. Also, because the instrument is cheaper and requires less maintenance than an high-field machine, we can have one dedicated instrument just for our lab, just for our use. So we can quite easily iterate, explore with this machine, because we can use it full time. We don't have to share it with other lab within the building. In terms of quality of the signal, it really gives us everything that we need as a first line of analysis. The Benchtop is the first line where we can throw everything at it, because it's a dedicated machine for the group. It can work 24/7, has low maintenance, doesn't need deuterated solvent. And once we have found which experiments are promising, then we can bring them to the more costly high-field machine. So the use of the Benchtop NMR was really to try to complement mass spec, because any of this technique is only giving you a partial answer regarding what is in your reaction mixture and what has happened. You cannot rely solely on one of these two instruments to get the full picture. The big advantage here is because we have a high throughput of data production, and we have insights in terms of analytical technique that are of quite high level, then it allows us to discover the unexpected. Is a reaction that you might not think would work turn out to give a very promising NMR signal on the Benchtop NMR. And then you can take this reaction and explore it fully on high-field machine and other analytical technique. And this has in fact led already once to the discovery of something that we were not expecting to start with. So one thing that we are trying to do at the moment is really put in place strategies to produce high-quality data set for chemistry that can be leveraged for data-driven discovery. The other thing that we are trying to do at the moment is extend the synthetic capabilities of our autonomous lab by integrating a new type of instrument where you can do further purification and multi-step synthesis on it, relying on the Benchtop NMR at every single step to make sure that you made the right product.